An AC bridge is a Wheatstone bridge. It has 4 arms in which we connect 4 impedances Z1, Z3, Z2, Z4. We connect these 2 opposite points to a signal generator and apply an AC voltage at a frequency more than 5 kHz for this bridge, and the opposite arms are connected to a multimeter to measure the voltage across these 2 opposite points. The Wheatstone bridge will be almost balanced when the magnitude of Z1 by magnitude of Z3 is equal to magnitude of Z2 by magnitude of Z4. There is a second condition for balance involving the phases, but this is a weak condition. You can realize 3 AC bridges with this box. Z1 and Z3 can be inductances, which are represented by the green banana terminals here. Z2 and Z4 will be resistances. Z2 is the pot which is adjusted for balance, and Z4 is a resistance represented by the black terminals. This bridge is called Maxwell's bridge. You can have Z1 and Z2 as capacitances, which are these yellow terminals, and Z2 and Z4 will again be the pot and a resistance. The third bridge is Z1 is an inductance, Z4 is a capacitance, R2 is always a resistance, and R3 will be a resistance which is here. This black and yellow terminal, they represent 2 different values of resistance. So we connect the signal generator, the output of the signal generator, to 2 terminals called signal generator in and signal generator out. This terminal, the terminal A and the terminal B, are connected internally. The signal generator out is connected to the terminal C. If we now connect A to a green terminal here, we put an inductance in the first arm. You can put 3 different inductances by connecting A to either L1 or L1 dash or L1 double dash. You can put 3 different inductance value in the first arm. When B is connected to a green terminal here, we put an inductance in the third arm. There are 2 inductances you can put, L3 and L3 dashed. When C is connected to the black terminal, you put a resistance in the fourth arm, and you can put 2 resistances, R4 and R4 dash. So for Maxwell's bridge, you connect A to one of the green plugs here, connect B to one of the green plugs here, and connect C to one of the black plugs here. After connecting them, you put these 2 switches down so that the pot is included or connected in the second arm. This gives you the AC voltage across the detector terminals. If I now turn this pot, the AC voltage will decrease and then it will reach a minimum value and then increase again. So you adjust this pot till you get a minimum value for the AC voltage, somewhere around this point. After adjusting for balance, you switch off these two switches and then measure the resistance of the pot by connecting an ohm meter to these two terminals. This ohm meter now shows 224 ohms. This resistance R4 is 220 ohms. L1 I don't know. L3 is about 3.5 millihenries. The condition for balance is L1 by L3 is R2 by R4. Now R4 is 240 ohms, R2 is 224 ohms, L3 is 3.5 millihenries. So L1 is L3 into R2 by R4, you can find L1. Then you can change this, you remove these two connections, change R4 from 220 ohms to 440 ohms. Put the switch down, now the balance is disturbed. You can again get the balance by turning this pot and getting the minimum, finding the position of the pot when you get the minimum output on the detector. So some point like this. Okay. Then switch off the two terminals and then measure the resistance. It is now 455 ohms. The previous measurement it was 225 ohms. This was 220 ohms, this is 440 ohms. So we have doubled R, so this R2 becomes doubled. So that L1 by L3 is R2 by R4. So you can calculate 4 values for L1 because you can change this inductance from 3.5 millihenries to something like 7 millihenries, double the value. And for each value of L1, you can have 2 values of R4. Therefore, for each L1 here, we will have 4 values obtained by balancing the bridge. Then you can change L1 to L1 dash, L1 double dash. So for Maxwell's bridge, you will get 12 values. Then you can go to the Sauty bridge by connecting the two capacitances. It will be a resistance here. Now this has become a Sauty bridge. And now you push this down and then adjust for minimum voltage. Okay, so that is the minimum. Then measure the resistance. It is 433 ohms. For capacitance, it is C3 by C1 is equal to R2 by R4. Because the impedance of a capacitance is 1 by omega C, whereas impedance of an inductance is omega L. So you can calculate C1. For each C1, you will get 4 values. There are 2 capacitances here, 2 resistances, and you have 3 capacitances in the first term. You will get 12 values for the Sauty bridge. The Maxwell-Wien bridge, you have an inductance here, that is A is connected to a green terminal, this is connected to a yellow terminal, Z4 is a capacitance, and this is a resistance Z3 which you connect here, and now you can do the balance. So here the minimum won't be close to 0 because 1 ohm is an inductance, 1 ohm is a capacitance, and the phase balance, that equation is badly disturbed. Therefore your minimum won't be 0, but minimum value is around here, and again you measure the resistance. I have 2 capacitances here. For each capacitance you have 3 inductances and 2 resistances. So for each capacitance you will get 6 values. You will get 12 values for the Maxwell-Wien bridge. If you want to give it in an exam, I have provided for external terminals. This is the external terminal for the arm 1, this is the external terminal for arm 2, this is the external terminal for arm 3 and arm 4. You can connect your own inductance here, you can connect a dial pattern resistance box here instead of the pot, and you can connect another inductance here and another resistance here. You can have your own values for the inductance. So in an exam you can change the values by using your own values.